This chapter is where the course truly begins. We now go and have a look at the Unix shell. We log in to a Unix system and examine some simple commands and log out again. Before we do that, we'll just have a look at what a Unix shell actually is. So, what is the Unix shell? Well, that begs the question, what is a shell? What is any kind of shell? You might want to pause the video at this point and have a bit of a think about that question to yourself. See if you can come up with a reasonable definition of what a shell is. You may have absolutely no idea at all, but it's important to actually think about the question. What is a shell? When we understand what a shell is, we'll hopefully understand what the Unix shell is. Okay, how did you go? What did you come up with? Well, I've got a reasonably simple definition that I use quite well. My definition is this. A shell is simply a program that is used to start other programs. That might sound rather simplistic, but it is actually quite an accurate working definition for a shell. Now, all operating systems have shells. Every operating system has a shell. Well, everyone that I know about anyway. So, have a bit of a think about the operating system that you're most familiar with using. Is it Windows 95 or DOS or 3.1 or something like that? See if you can think of what the shell is for those particular operating systems. For example, I'll go through the three most popular Microsoft flavors of operating system. What is the shell for DOS? Can you think about that? What is the shell for DOS? What is the shell for Windows 3.1? Remember Windows 3.1? Some people are still using it. And what is the shell for the current generation of Windows, which is Windows 95, Windows 98, Windows NT 4, Windows 2000 and Windows XP, and even Windows ME. All those flavors of Unix share the same shell. Does anybody know what that shell is? Okay, had a bit of a think about it? Alright, well, here's the answer to those three questions. DOS's shell is command.com. That's the thing that gives you the little C prompt. Windows 3.1, or an early version of Windows NT, the shell for those operating systems was the Program Manager. Even though Windows 3.1 is not truly an operating system, it still has a shell. The shell was the Program Manager. You notice that command.com and Program Manager are both programs that are used to start other programs. They're very different, however. Command.com is a text-based command line shell, in the sense that you type in the name of the program that you wish to run and then you press enter and then the program is started. In that sense it is very like the Unix shell, but it is far more rudimentary and simple than the Unix shell. On the other hand, the Program Manager is a graphical shell. It is used with a mouse. If you want to start a program, you simply double-click on the icon that represents that program. You don't need to know the name of the program. All you need to know is what the icon looks like. Consequently, such shells make the operating system much easier to use. A good shell can make or break the popularity of an operating system. Finally, in the latest series of Windows operating systems, the Windows Explorer is used as the shell. The Windows Explorer is the program that is responsible for putting the Start menu in the lower left-hand corner of the screen. It's also the program responsible for putting the My Computer icon and the My Documents icon on the desktop. In fact, it's the program responsible for there being a desktop. These are three quite different shells. Okay, let's move on. Let's have a look at another way in which a shell can be thought of. This is where the actual word shell came from. You can think of it as a layer of software that sits in between the operating system and the end user. Or it can also sit in between the operating system and any other programs that you might run, any applications. So the diagram looks something like this. You start with the operating system in the middle, and you then add a layer around that, which you might call the shell. You could even say you could add a shell around that, which is kind of like an eggshell. And finally, you add the other programs and the end user to the outside of that. So what this kind of implies is that the other programs and the end user interact with the shell, and the shell interacts with the operating system. Now this is a very popular way of talking about shells, but it's not entirely accurate. The end user interacts with the other programs as well, so the end user could be, if you like, another layer around the outside of that, and also the other programs involved can interact directly with the operating system. So it's not entirely an accurate diagram. It's a very popular diagram, but I don't like it all that much because it is a bit misleading. However, it is somewhat tricky to draw a truly accurate diagram of this nature. So I'll simply say it verbally. What can interact with the operating system? The shell or other programs? What can interact with the shell? Well, the end user. The shell is also used to start the other programs. And what does the end user interact with? Well, the end user interacts with the other programs or the shell. Okay, that's a nice, simple and accurate summary, but it doesn't entirely reflect the diagram that's in front of you at the moment. So let's move on now and talk about the Unix shell. The discussion so far has been about shells in general. Now, the Unix shell is text-based. It's not a graphical shell like Program Manager or Explorer. It's text-based and it's command line driven, which means that you must type in the name of the program that you wish to start in order to start that program, which means of course that you have to remember the name of the program that you want to start. That's often the hardest part. The way it works is that you type a line of text against a prompt. We'll have a look at what a prompt is in a second. You type a line of text, then you press enter, and the line of text that you have typed is interpreted by the shell as a single program that you wish to start. And it looks like this. Here's a little example of what a shell might look like were you to run one. It might start, as soon as you start the shell, it might say, welcome to Unix or have a nice day or something like that. And then you might get a little $sign. You don't always get a $sign, but it's very common to get a $sign, and the $sign just sits there waiting for you to type something. It doesn't do anything at all, it just sits there. So you type something. In this case, I've typed ls, which is the name of a program that I wish to run. ls lists the contents of the current directory. So the contents of the current directory might be documents, readme.txt, and output.file. So the output of the ls program is the 3 lines underneath ls. When ls is finished, the shell notices that and puts a little $sign up with a little flashing cursor saying essentially, okay, I've done that, what do you want me to do now? And you keep typing in the names of programs until you have nothing further to do. In a moment we're going to see some live demonstrations of exactly this process. Before we do, we need to actually ascertain which shell you are planning to use. There are actually several shells available in Unix for you to log in and use. You typically only use one at a time, but they're all subtly different, and it's worthwhile examining just which one is which. It's also worthwhile you trying to find out, if you can, what shell you are running on the Unix system that you are running.